Okay, 212. So, today what we're going to talk about is the binomial theorem. Binomial theorem and Pascal's triangle. Pascal's triangle, yeah. So, binomial. We talked about that. I think when you guys were in algebra, we talked about Pascal's triangle.
Yeah,
Cole.
we did.
Yeah, and we did it for flipping a coin, right?
Mm-hmm.
So, the whole idea of binomial means two things, right? Binomial means two things. And so if you take a look at example 1, that's a binomial, right? A plus B, that's a binomial, okay? So the binomial theorem and Pascal's triangle we did in algebra because we talked about flipping a coin. And what Pascal's triangle did is gave us all the combinations, all the possible combinations of flipping, say, 5 coins. Remember that? Or 4 coins. We used Pascal's triangle to tell us all the combinations. Now, if you didn't have me for Algebra 1, then you probably haven't learned Pascal's triangle. But the kids who did, I'm going to show it to you again how it can help us with the binomial theorem. So right off the bat, if I had to do this, if I had to do, A plus B, A plus B, A plus B, possibly on this one, because it's only at the cube, I might beg Pascal's triangle. Maybe not. So what I would do first is do these two first, and I'd multiply it out.
Staff and students, please excuse the interruption. We do have one more bus that's on its way in, should be here in about 10 minutes. So staff, continue to allow students in. Appreciate it. Thank you.
Yep. So I'm going to do these first. A squared plus AB, right? Now B times A is BA, or how about AB also, right? Plus AB, all right? So B times A is BA, or let's just write as AB, okay? And then B times B is a B squared, okay? So again, B times A is BA, but we can write as AB. And the reason I want to do this is because then I can add these two, okay? So I can have A squared plus 2AB plus a B squared, okay? But I'm not done. I'm not done because now I need to also do the A plus B here. So, okay, now it's just going to be what I call the superfoil. A cubed plus a 2A squared B plus an AB squared. Okay, how am I doing? I'm doing okay? I'm going to go B times A squared is a squared B. So I'm going to put that there. 1A squared B. A B times a 2AB is going to be a positive 2AB squared. And the B times the B squared is a B cubed. All right? Do you want me to slow down for a second, let you catch up? It's a little confusing, isn't it? But A times B, B times A. AB, BA, same thing, right? AB, BA, same thing, okay? So if I add everything, I'm going to get an A cubed plus a 3A squared B plus a 3AB squared plus a 1B cubed, okay? Now, example 2. I don't want to do it that way. I want a trick, and the trick comes from Pascal's triangle, okay? So Pascal's triangle. Here's how Pascal's triangle works. Start with a 1, okay? And then I'm going to go another 1, 1.
Oh, like in our books.
You've seen it. Yeah, actually in our little book it had Pascal's triangle. Then I'm going to go 1, 2, 1. Now here's how Pascal's triangle is made. You're going to always start with a 1 on the outside, and then you're going to add these two. I'm going to say it again. You're going to add these two. 1 plus 2 is 3. 2 plus 1 is 3, and then a 1. Always start and end with a 1 on Pascal's triangle. So the fourth row of Pascal's triangle is 1. 1 plus 3 is 4. 3 plus 3 is 6. 3 plus 1 is 4, and then end with a 1. That's the fourth row of Pascal's triangle. Okay, then we do the fifth row. 1. 1 plus 4 is 5. 4 plus 6 is 10. 6 plus 4 is 10. 4 plus 1 is 5, and then another 1. Okay? Now, how does that help us? Well, let's look at example 2. And I probably need to do example 2 on a separate sheet of paper because I don't think it's going to fit. Okay? But let me do example 2. And we're going to use Pascal's triangle. So I'm going to go example 2. I have a parentheses a plus b to the 4th. Okay? I'm going to show you how Pascal's triangle works. All right? So it's to the 4th power. So I want to use the 4th row of Pascal's triangle. Okay? To the 4th power, I need to use the 4th row of Pascal's triangle. So, okay, I'm going to go to my 4th row. And my 4th row is the one, here's my 4th row. This is the 0 row. Because anything to the 0 power is 1, right? This is my first row, which would be just an a plus b. This would be like an a plus b to the, so this is like an a plus b to the 0 power. This is like an a plus b to the 1 power. This would be like an a plus b squared, a plus b to the 3rd, a plus b to the 4th. So we're going to use the 4th row. So this is my first row, 2nd row, 3rd row, 4th row. Okay? 0. So that's my first row, my 2nd row, my 3rd row, and my 4th row. Okay? When we were in algebra, we talked about the fact if you flip 2 coins, for instance, flip 2 coins, there's 4 ways to get 1 heads and 3 tails. There's 6 ways to get 2 heads and 2 tails. That's why we did it in algebra. We're going to do it differently, though. We're going to use it to help us do these binomials, okay? So I went to the 4th row. So let's write that down. 1, 4, 6, 4, 1, right? Go straight to the 4th row of Pascal's triangle and write down these numbers, okay? Went to the 4th row of Pascal's triangle because it's to the 4th power, 4th row. So I wrote down my 1, 4, 6, 4, 1. So far, so good? Now, we know from what we've been doing, look at our previous example, a cubed, a squared, a1, no a's. You see that? See the pattern? A cubed, a squared, 1a, no a's. And on the back, b cubed, b squared, b to the 1, no b's. Because we're the same thing, but we're going to do it with the 4th. So I'm going to start out with an a to the 4th, because I would have an a to the 4th. Agreed? I'm going to have an a cubed. I'm going to have an a squared, a, and then no a's. See the pattern? Oh, the same thing with the b's. I'll have a b to the 4th, a b to the 3rd, I'll have a b to the 2nd, I'll have a b to the 1, and then no b's. Plus, 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 and we are done. If you were to multiply and write this out, a plus b, don't do it though, a plus b times a plus b times a plus b. If you were to do it this way and go, this times this, 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 then this times this, this times this, this times this, this times this, then that times that, that times that, that times that. Right? You got the idea? If you were to do all that, this would be your answer. It would be. If you don't believe me, try it. I don't want to try it because I know that's the answer. Isn't that slick? Daisy.
I just concerned. I probably wrote this down right. I wrote a cubed for my answer instead of a to the 4th.
Right. So if I did an a cubed,
Oh, I see.
but I did an a to the 4th. So if we did an a to the 5th, right? If we did, for instance, an a plus b to the 5th, right? We'd find the 5th row of Pascal's triangle, right? And I'd go my 1, 5, 10, 10, 5, 1. And instead of writing it out 5 times and doing a superfoil, the answer would be simply this. It would be an a to the 5th plus a4b plus a3b squared plus 10a squared b cubed plus 5a, let's see, b to the 4th plus a b to the 5th. Okay, that would be it. See the pattern? So I needed the coefficients. The coefficients come from Pascal's triangle, right? And then I saw the pattern. It's going to be, I know it's going to be a to the 5th in the front, all the way down. I know it's going to be to the 5th in the back and all the way up. Everybody see the pattern? Okay, because we're going to change it up. We're going to still use this pattern, but it's not going to be just A's and B's. Okay, but everybody good on that? Okay, now turn the page. Okay, now what about example 3? Well, to do example 3, it's X's and 3's. So what we're going to do is this. We're going to rewrite it. We're going to let A equal 2x, and we'll let B equal 3. Okay? And we're still going to use the binomial theorem and Pascal's triangle. Okay? So before we do anything, we just did a to the 4th, right? And we're going to do it again. And then we're going to substitute in what a is, 2x, and we're going to substitute in what b is, which is 3. So let's do it again, okay? Pascal's triangle. Let's first just do a plus b to the 4th, and then we'll substitute in 2x and 3 when we're done. Everybody good on that? Okay, so let's do it. 4th row of Pascal's triangle is going to be my, okay, 4th row of Pascal's triangle. And we're doing 4th row because it's to the 4th power, right? So we're going to first start with a 1, 4, 6, 4, 1, okay? And then we're going to put our a to the 4th, a to the 3rd, a2, a, and then no a's, okay? You guys see the pattern. I'm hoping you see the pattern, right? And then we're going to go to b to the 4th, b to the 3rd, b squared, b, and then no b, right? Okay, right? So far so good. Plus signs in between, plus, 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 plus. Okay, how am I doing? Now, all we need to do now, and it gets a little bit complex, but we're going to substitute 2x for all my a's, right? And we're going to substitute my 3 for all my b's, right? So it's going to look like this. We're going to have a 1. Parentheses 2x to the 4th. Okay, so I'm just simply putting 2x in for a plus 4. And I'm going to substitute in 2x for my a, which is going to be a 2x to the 3rd, times my b. So I'll times it by 3 because I'm going to substitute b for 3. Because this problem isn't about a's and b's, it's about x's, 2x's, and 3's, right? Plus 6. A squared. I'm going to substitute in 2x for my a, but 2x squared, times my b, which is going to be 3 squared, plus 4. Again, I'm going to substitute in 2x for my a, and I'm going to substitute in my 3 for my b, or 3 cubed, okay? Scoot it over, plus 1 times b to the 4th, so 3 to the 4th, okay? Now, that wasn't hard. The tricky part now is just to make sure I simplify correctly, okay? I don't want to make any dumb mistakes, which I'm famous for, right? So hopefully I won't make any dumb mistakes. Now, we got to be careful. We've got to take 2 to the 4th power as well as x. So this is going to be a 16, okay? 16 because 2 times 2 times 2 times 2, 16x to the 4th, times 1, but I don't need the 1, okay? You guys okay with 16?
Yeah.
Plus, now I'm going to do this in a couple of steps. 4 times 8x cubed times 3. Okay, I'm going to do it in 2 steps to finish up. Okay. Okay, so I've got my 8x cubed times 3 plus 6 times 4x squared times 9. Okay, you okay with 4x squared times 9 plus 4 times 2x times 27. Plus 1 times 81, because that's 3 times 3 times 3 times 3. Thumbs up. Now it's just a matter of like letting the calculator do the multiplication for me, because, you know, so I'm going to have an answer of 16x to the 4th plus, all right, this is going to be a 4 times 8 times 3. So I'm just multiplying 4 times 8 times 3, let my calculator do it. I got a 96x cubed, okay? I just went 4 times 8 times 3, and I got 96 x cubed plus 6 times 4 times 9. 6 times 4 times 9, and I get an answer of 216 x squared plus 4 times 2 times 27. 4 times 2 times 27, another 216 x plus 81, and that is the answer. That is. I mean, if we were to multiply it all out, this is still tedious, but believe it or not, it's a lot easier than multiplying it all out. Would you agree with that? It's easier? Okay, let's look at our journal real quick on page 69, okay?